Now we'll define some special vectors called unit vectors. As the name suggests, their length is 1 unit. Okay, and it turns out, and these will be dimensionless vectors. So what that means is, well, you can use this with any quantity. You can use these unit vectors to specify forces, accelerations, and so on. And you'll see in a second the dimensions will be associated with the components. Okay, so unit vectors. What are these unit vectors? They're denoted by I, J, K, or some authors use X, Y hat, Z hat, and various other notations. So anyway, so these are unit vectors. I is a unit vector that points along the x-axis. J is a unit vector that points along the y-axis. And K is a unit vector that points along the z-axis. And as I said, their length is 1 unit. Okay. This is a right-handed coordinate system, and we'll exclusively use a right-handed coordinate system x, y, z. And what I mean by a right-handed coordinate system is you think of as a right-handed screw. As you turn from x to y, the screw will move in the z direction. So as you turn the screw from x to y, the screw would move in the z direction. That's a right-handed coordinate system. A right-handed screw would move that way. Okay. So these are unit vectors are dimensionless vectors of magnitude unity. All right, so here is a so what we did was you learned how to add and subtract vectors graphically, but that's not practical when you want to do calculations. So we will learn how to add vectors algebraically. But before we do that, we need to write components of a vector. Okay, so here is a vector A that's written as the sum of a vector along the x-axis plus a vector along the y-axis. Okay, so so this vector A is written as a vector along the x-axis and a vector along the y-axis. And this vector along the x-axis is a scalar, some number, times the unit vector along the x-axis. And this vector along the y-axis is a number times the unit vector along the y-axis. Okay, so for instance, let's say, okay, and what I'll do is rather than using x hat and y hat, I'll use I and j, because that's what I'm used to. I plus 6j. Okay. So what does this mean? See, this is the vector because that was a vector, and 5 times that vector is a vector 5 units long, and 6 times this is a vector. And all this equation is saying to us is this vector is equal to this vector plus this vector. Okay, so let's see graphically what does that mean. Here's 5i. Okay, so by the way, so here was our x-axis and there's our y-axis. There's 5i and there's 6j. Okay, j was the unit vector along the y-axis. Okay, and so a is the sum of those two vectors, so this is a. Okay. So what you have done by doing this is written a vector in component form. This is called the x component of the vector, and this guy is called the y component of the vector. So that's what this notation is. There's the x component of the vector, I plus y component of the vector times j. Okay. And it turns out that in 2 dimensions, the components are related to the magnitude and direction like by these equations. So the x component is the magnitude of A, which is the length of A, times this angle, theta, where theta is measured from the x-axis in the counterclockwise direction. So for a vector like this, so there's the x-axis, y-axis, and if the vector were like this, this would be theta. You're always measuring it counterclockwise from the x-axis. All right, so the x component of A is A cosine theta, the y component is A sine theta. And so this is getting the components from magnitude and direction. And if you wanted to go the other way, if you wanted to get magnitude and direction from the components, here's how you do it. The magnitude is ax squared plus ay squared, square root of that. So here's the magnitude from the components, and the angle is tan inverse of ay over ax. Okay. All right, so now we've learned to write a vector in component form, and we've learned how to go back and forth from component to magnitude and direction. So we've learned how to go from magnitude and direction to components and vice versa. Of course, you can give a vector in any format and it contains the same amount of information. Okay, so components to magnitude and direction, back and forth. Now the reason we did this is because now adding and subtracting vectors becomes super easy. Alright, so we'll do one last signs of the component. If a vector is in the first quadrant, it will have if a vector is in the first quadrant, its x and y component will be positive. If it's in the second quadrant, x component is negative and y component is positive. And when a vector is in the third quadrant, both its components are negative. And here the x component is positive and y component is negative. All right. All right, let's stop this here.